Hello everyone, my name is Faris and today we'll be talking about the last workshop topic, an introduction to deep learning. So in this workshop, we'll be learning how to create a basic fully net connected neural network architecture to solve the basic ML problems of regression and classification, along with an introduction into how the deep learning protocol improves itself using things like dropout, batch normalization, and other techniques. So, what is deep learning? You can think of deep learning as a part of machine learning, which is itself a subset of artificial intelligence. But the difference between deep learning and machine learning is that instead of the human creating an algorithm for the machine to solve a problem, instead, deep learning uses all of the available data that it has to create its own algorithm to solve the problem. And throughout the past years, we have seen great advancements in deep learning, which has allowed us to use that protocol for things like natural language transition, image recognition, and game playing, a lot of which have far exceeded human capabilities. And deep learning is basically characterized by what we call deep stacks of computations, which in itself is inspired by how the human brain solves problems. So we know that in the human brain, we have all of these trillions of neurons, each connected with each other or a subset of each other to pass in bits of information, one activating the another to finally create this amazing brain that can solve virtually any problems that you give it given time and resources. And true enough, the deep learning protocol takes inspiration from this model to use all of these seemingly simple individual neurons that each connect with each other to solve a bigger problem. So fundamentally, you can think of the neural network as composed of individual neurons. So in a diagram, a neuron can look something like this. We have an input X that goes through an intermediary layer, which outputs an output Y. And the way how the most basic linear unit works is much like how the most basic unit of the brain works. A couple of neurons connect to one neuron, and each of those input neurons will either be a 1 or a 0, and they will have essentially what we call weights between the input and the output. The input, which is either 1 or 0, will be multiplied by the weights, and all of that will be summed up to each other to produce a final result, which if it crosses a certain threshold will activate the output neuron. So similarly in deep learning, this is how it works. We have an input which is multiplied by its weight, which we call W, and then passing through an intermediary layer to output Y. So the value of Y will be exactly equal to W times X plus B times 1, where B is what we call a bias. So a bias is a way for the protocol to fix itself independent of the input, because for example, if I were to change the value of W, that will essentially influence the input, how much of the input that I am receiving, but that can sometimes be a problem if you want more minute modifications. So we introduce a bias here.